In a secret part of Malaysia known to nobody, lives four of the strongest human beings in the world. Sewon from Ermey in the north, Shui Yun from Kunlun in the south, Keng Seng from Wudang in the east, and the strongest among them, Anson from Shaolin in the west. All of them live in harmony until one day, Sewon, Shui Yun, and Keng Seng combine force and intend to defeat Anson from Shaolin once and for all. Anson have no other choice. He found a secret kung fu hidden in the world. YouTube. After all, we are all humans. We grow old and got injured easily. We cannot run away from fate. Thanks to biomedical engineering, you can still walk as a normal person. Hi, I'm Anson, KIB2003, and I'll be talking about the introduction part. Firstly, we need to know what is an anterior cruciate ligament tear. The anterior cruciate ligament ACL is one of the key ligaments that help stabilize your knee joint. The ACL connects your thigh bone femur to your shin bone tibia. An ACL injury is a tear or sprain of the anterior cruciate ligament ACL. ACL injuries most commonly occur during sports that involve sudden stops or changes in direction, jumping and landing. Next, we will know more about hinge knee brace. Knee braces are commonly prescribed by physicians for patients who have an ACL tear or some type of knee injury. A post-operative knee brace is used after a surgery such as anterior cruciate ligament ACL reconstruction surgery. The knee brace allows some knee immobilization by limiting the degree of flexion and extension of the leg. This can be done by adjusting the hinge on the brace, and it is important to provide a controlled range or motion as the patient knee heals. We will now talk about the mechanics of material in hinge knee brace. For LO1, axial loading is defined as applying a force on a structure directly along an axis on a structure. In our case, it will be the load applying on the x-axis and y-axis at the hinge part of the knee brace. Also for LO1, torsional load. When the knee brace sustains torsional load, we must be able to calculate the amount of twist produced and the shear stress set up to ensure that it won't break. For LO2, stresses on the knee brace. By knowing the maximum stress is applied to the knee brace based on the weight of the wearer and the Young modulus of the material used by the knee brace, we can better design the knee brace so that it is able to withstand the stress produced. For LO3, stress and deformation of the knee brace due to compound load. By using the maximum stress applied to the knee brace, using strain formula, we are able to get the change in length, which is the deformation of the knee brace.
I'm new to you, KIB2003. So for methodology, in first step, the free body diagram of the hinge knee braces was drawn. All the external forces acting on the object were labeled, and the force vectors were resolved into x and y components as the picture. The max of test subject, net flexion angle, diameter of box, length, width, and diameter of beam were measured. Young's modulus of the steel box was calculated. For LO1, load in terms of axial Vx and Vy were calculated using the equation Vx equal to mass times gravitational force, while load in terms of torsional Ml was calculated using the equation moment equal to force times diameter. For LO2, the axial and bearing stress occur at the beam, while shearing stress occur at the box were calculated by using the equation stress equal to force per area. For LO3, the axial bearing and shearing strength were calculated with the equation strength equal to stress per Young's modulus. Both the deformation occurred at the beam and box were calculated with the equation deformation equal to strength times length. For LO4, the ways on how to improve the design of hinge knee brace were discussed. Moving to the result and discussion part, these are the exchange values for each component. So for LO1, in terms of action load, we have to consider the body weight which is acting downwards. The weight has to times sin 45 degree for Vx and cos 45 degree for Vy. In the end, for both of it, we will get the value of 228.91 Newton. While for torsional load, we have to consider about the load that causes turning effect. We use the equation of moment, and we will get 57.23 Newton meter.
Hi, my name is Kui7, metric number KIB200317. Now I'm going to talk about the calculation part for LO2, which is solving problems involving stress in beam. For the axial stress of beam, which occur at the blue color part shown in the diagram, the area is equal to T, which is the thickness of the beam multiplied by W minus D. W is the width of the beam minus the diameter of the bolt. So the answer will be equal to 1 times 10 power to negative 4 meters squared. For the stress, which is denoted by the sigma symbol, is equal to pressure over area. So the pressure we get from the LO1 just now, so we substitute it inside, divided by the area we get just now. So the answer will be equal to 2.2891 megapascal. For the shearing stress of both, which occur at the red color part shown in the diagram, the area will be equal to pi d squared over 4. The d here is equal to the diameter of the bolt. So we will get the answer of 1.7671 times 10 power to negative 4 meters squared. For the stress, we get it using the same formula, which is the stress equals to pressure over area. So the answer will be 1.295 megapascal. For the bearing stress of beam, which occur at the red color part shown in the diagram, the area equals to Td. The T here is the thickness of the beam multiplied by the D, which is the diameter of the bolt. So the answer will be equal to 1.5 times 10 power to negative 4 meters squared. For the stress, we also use the formula stress equal to P over A, pressure over area, so we will get the answer 1.526 megapascal. Next, I will talk about LO3, which is evaluate stress and deformation of biomedical devices due to compound load. For axial strength, it is equal to axial stress over Young modulus of steel, which is 180 times 10 power to 9. So the strength we get will be equal to 1.272 times 10 power to negative 5. For the deformation of beam caused by axial force, it can be get through the formula deformation equals to strength times length of the beam, which is equal to 0.25 m. So the answer we get will be equal to 3.18 times 10 power to negative 6 meter. For the shearing strength, we can get through the formula shearing stress over Young modulus. So the answer will be equal to 7.194 times 10 power to negative 6. For the deformation of bolts caused by the shearing force, it will be equal to shearing strength times length, which is the half of the thickness of the bolt. So the answer will be equal to 3.597 times 10 power to negative 8 meter. Last, for the bearing strength, we can get it through the formula bearing stress over Young modulus. So we can get the answer, which is 8.478 times 10 power to negative 6. For the deformation of beam caused by the bearing force, we can get it through the formula elongation equals to bearing strength times length, which is equals to length of the beam, so which is 0.25 meters. So the answer we get is 2.12 times 10 power to negative 6 meter. For the deformation of bolts caused by the bearing force, we use the same formula as the deformation of beam caused by the bearing force. So We just replace the length here with the diameter of both, since we need to find the deformation of both. So the answer will be equal to 1.272 times 10 power to negative 7 meter.
My name is Keng Sing, and I will continue to talk about the discussion. A knee brace is a biomedical engineering field device that can support and stabilize an injured knee. A hinge knee brace are excellent for knees that needs extra support. For a real-life example, an ACL injured knee. An ACL sprain and tear are very common injury, as there are approximately 100,000 to 200,000 incidents that are reported in the United States every year. A hinge knee brace is excellent for ACL knee injuries, as the injured knee needs support for it to heal. This is an example of how to design a hinge knee brace. In this report, the knee brace is using a bilateral hinge joint. A triaxial hinge brace gives better natural movement for the knee. The user will feel less restrictive, whilst essential offering the same level of support to the joint comparing to a standard hinge. The formula of stress is stress equals to force over area. Since force is an uncontrollable factor in our case, we should focus on the area. As the area of the pivot increases, the stress decreases. To achieve that, we can design a larger cross-sectional area between the knee brace. We can also design a knee brace with larger area of skin contact. The knee brace will be more comfortable for the user because the stress is more distributed and less focused on a point. The material of the hinge joint should be lightweight and strong, because it is not ideal to have an injured person to wear a heavy device and to support the injured leg. For example, a magnesium or an aluminium.
In conclusion, mechanics or materials can be applied in the biomedical field, such as a hinge knee brace. We have investigated all of the 4 LOs with the hinge knee brace as real-life case. I believe with the knowledge learned in mechanics or materials, we can make sure the design in the hinge knee brace is safe to use. That's all from my group. Thank you.